Now previously we talked about circles. Now we get a circle if we have the same coefficients in front of our x squared and our y squared, because when you divide through, they wouldn't have a coefficient there, right? Well, let's think about what's going to happen if instead of dividing through by 9, we divided through by 225 instead. There is a method to this madness, by the way, so just follow through with me. Just roll with it. So if I look at what goes into 225, let's see. Oh, that's going to give me x squared over 25 plus y squared over 25 equals 1. So notice the denominator of each fraction is the radius of the circle, squared, right? Because our radius is 5 squared. Now what happens if the coefficients are not equal? Let's take a situation like this. What if we have 9x squared plus 25y squared equals 225? What's going to happen on this one if I divide through by 225? I'll get x squared over 25 here, but here it changes. This is going to be y squared over 9 equals 1. So notice that the denominators are different this time. Under x squared, we have 25, and under y squared, we have 9. Also notice that our center hasn't changed, because we're not changing what's being subtracted from x or y. So the center is not changed. What has changed? Now I want you to really think about this. In a circle, if I do this little trick and get 1 by itself over here, the denominators here are exactly the same. Here, they're different. What do you think is going to happen to the graph? Well, I'll go ahead and be honest with you. What's going to happen is that you're going to have one side as wider than the other side. And let's think about which side's going to be wider. Now, if both of them had 25, then our radius would be 5, right? Going from the center. We go out 5 in all 4 directions. But since y squared has 9 underneath it, what do you think we're going to go, how far we're going to go up and down? You're absolutely right. We would go 3 up and down. So let's actually go into this a little bit more detail. What we're talking about is a figure. It's a little bit lopsided. It's called an ellipse. Now, an ellipse is similar to a circle, except for it goes out wider or taller, depending on what you have. Now, the technical definition of an ellipse, it's the set of all points in a plane in which the sum of the focal radii is constant. I want to explain what that really means. In a circle, we have one center, right? What we have in an ellipse is instead of having one center, now it does kind of start off at the center, but we have what are called foci, evenly spaced from the center. Now, every point that comes out of here, if I added up the distance from these two foci to the edge of the ellipse, I get Ellipse. And we can try this out by using string and a pencil going from these 2 points. And you'll actually do that in one of your activities. Now these are the foci, or focus, singular focus and a focus, together foci. We have the center. And we have what is called the major and the minor axis. Now believe it or not, go with how you want it. The major axis is the big one. So we could have it turning upside this way, or this way, doesn't matter. But the major axis is going to be the one that goes through here, the larger one. Your minor axis would be how far you're going up or down. So in that first activity, we had x squared over 25 plus y squared over 9 equals 1. What would be my major axis and my minor axis? Well, my major axis would actually be the horizontal axis on this one. And the minor axis would be the vertical. Now, A is always, well, basically half of your major axis. So it'd be from here to here. That would be your A. And B is going to be half of our minor axis. So we get this idea here. Now, so for this one, A would be 5 and B would be 3. So we have our major axis and our minor axis. Now, finding out how far these foci are takes a little bit of work. The foci are found by adding or subtracting C, this value C, which tells me how far away my focus is from the center. Now I can find C by taking the difference of my major axis, or the A squared minus the B squared. So for this example, we already said our center was 0, 0, right? To find C, C squared is going to be the difference of my denominators, really. So it's 25 minus 9, which is 16. So in this example, my focus is going to be 4 units away. Now, since it's a horizontal ellipse, I'd be 4 units to the right, which is 4, 0, and 4 units to the left. Now, just to make sure we know, we can also have a vertical ellipse. It would just, the y squared would have the larger one, larger denominator. Now, for any of them, we have x minus h squared, and I'm just going to go ahead and do the horizontal, a squared. If the y is in front, you have a vertical one. If your x is in front, you have a horizontal one. Now let's look at one where we can sketch the graph, and then we're going to take a pretty hard one for an example. Let's sketch the graph of, let's see, we have 25x squared plus 9y squared minus 200x plus 18y plus 184 equals 0. So I want to do a pretty difficult one so we could practice that completing the square. Our first step is to group our variables. Whoops, 18y. And I'm going to move that 184 to the other side. Now I'm going to rewrite it one more time and I'm going to factor out that leading coefficient. So I get x squared minus, let's see, 25, that'd be 8x. And I need to leave some space. Remember, when we complete the square, we're going to add something there. Now for the y's, we're going to be factoring out a 9 because it's what they both have in common. Leave a little space. All right. Remember, completing the square. I want this to be something squared. I want this to be something squared. Now, since this is x, this will be x. Since this is y, this will be y. Now comes the fun part. How is the number next to the x related to the middle term here? Well, it's half. So if I take half of that, I get a negative 4. So what's missing? What's that negative 4 squared? And that's plus 16. Now, to be careful there, because it's not just a 16. There's that 25 out front. So I'm really going to add a 25 times 16. For the y's, I want to be very careful there as well. Half of the 2 is going to give me a 1. That squared is 1. So I need to add the 1, but that's actually a 9 times 1. So I'm also going to add here a 9, well, times 1, which is just 9. So let's take a second and figure out what is, let's see, if I take negative 184 plus 25 times 16 plus 9 times 1, I get 225. Now, for these ellipses, we want to have that 1 on the right side. So we're going to do what we did in the warm-up and divide everything by the 225. So 25 goes into the 225 9 times. I get x minus 4 squared over 9. So it's going to be y plus 1 squared over 25 equals 1. So let's talk about everything we know. What's the center? The center is still made by the shifts in the x and the y here. So x minus 4 means we're right 4, down 1, so it's minus 1. Our a, this is the a squared. It is our major axis. Minor axis over here. So this is the major, and this is the minor. So A is going to be 5, and B is going to be 3. But we got to remember which way they are. Now, to find our C, C squared equals the difference. So that's 25 minus 9, which is 16 again. Being really nice here. So it's 4 units away. Now, let's talk about how this would look. Center, 1, 2, 3, 4, down 1. This is going to tell me how far I'm going up and down. It's going to tell me 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This tells me my horizontal. So it's telling me I'm going right and left 3. Now, that is my ellipse. What if I wanted to find my foci? My foci are 4 units from the center. Now, since it's a vertical one, they're 4 units up and then 4 units down. So if I go from that center and go 4 units up, 1, 2, 3, 4. I started out at negative 1. 1, 2, 3, 4. So I'd have 1 at 4, comma, 3. The other one, I'm going to go down 4. So negative 1, negative 2, negative 3, negative 4, negative 5. And that's how you find your foci.